Hello and welcome back to Inclusive Design 24 2020, brought to you with thanks to our Platinum supporters, Barclays Access and Adobe. A reminder that ID24 is a respectful community, and you'll find our code of conduct linked off every page of our website, inclusivedesign24.org. You can follow the action. We're on Twitter as @ID24conf. And if you have questions for our next presenter, just use the ID24 hashtag and we will ask them, time permitting, at the end of the talk. Hida, who do we have up next?
So next we have Jyothi Kamau, and she'll be talking about bias in artificial intelligence. Over to you, Jyothi.
Thank you for the introduction, and thank you to anyone who is watching my presentation today or will be catching up later on. My name is Jyothi Kamau, and I'm a UX UI designer, and today I'm going to be talking about two prevalent biases in AI, which is healthcare and profiling. As someone who has delved deep into WCAG guidelines, read material design a few times, and written a piece on inclusivity, I felt that I wanted to broaden my horizons. I'd always been interested in machines, so to meld that interest with inclusivity was really interesting to me. Also, one of my favorite movies is iRobot. So to give an idea about the outline of this talk, it'll look like this. Begin with defining some terms that'll be prevalent to the clarity of this talk, segue into the history of AI, and then discuss the shortcomings and errors that people face when dealing with AI technology. In a lot of cases, people find it difficult to separate the definitions of artificial intelligence, machine learning, and deep learning. So to kick off, we'll start by unpacking and defining these concepts. Artificial intelligence is a branch of computer science that's mainly concerned with constructing intelligent machines capable of performing tasks that, in most cases, need humans to achieve. It's a science that combines more than one discipline. Machine learning is a subdiscipline of artificial intelligence. This is where the computer algorithms understand how to associate particular patterns and turn that into future predictions. It uses a wider breadth of statistical methods that are actually used quite a bit in medicine. What separates machine learning and deep learning is that deep learning isn't based much on assumptions, but on understanding more complicated data input. And finally, deep learning is a method that lets us input large amounts of raw data in order to uncover representations needed to detect and classify. It heavily depends on diversity and several layers of representation that are important to sidestep any discrimination and quash unimportant variations in data. In all, deep learning is very much relied on for much of the initial improvements in machine learning. So how does artificial intelligence actually work? AI is a system where once it learns something from particular sets of data, its goal is to use that data to make sense of future scenarios and situations never seen before. Many artificial intelligence systems are constructed and trained by using biased data provided by humans, who are unsurprisingly biased. Due to this, systems find themselves outputting unknowingly discriminatory information against particular races, which often leads to group profiling and implicit bias. This worrisome failure lies in the algorithmic model and data. And before we can move forward any further with AI, we need to retrain and master these broken systems. Naturally, algorithms used in artificial intelligence, also used in machine learning and deep learning, are based on pattern matching, or in other words, repeated data information. So if a system is continuously given biased data, it'll end up reflecting that through its algorithm. For example, if a particular demographic is continuously given a label, whether pertaining to personality, occupation, socioeconomic status, body type, and more, the system will eventually start to pick up on a pattern. This is the beginning of implicit bias. In fact, this can be a really dangerous feature of AI, for example, false criminal recognition. What needs to be done is an examination of that pattern making while simultaneously trying to deconstruct those issues. Because as AI increases, the importance to rid that complication becomes of increased importance. Identifying and understanding how to halt artificial intelligence's systems failures is what will build a better future for the relationship between humans and machine. Before we get into racial bias and healthcare, I want to dive into the history of AI and give a good background explanation about its journey from the 60s to the 2010s. Until the past few years or so, majority of AI was maybe just seen as tech stuff in movies like Her, Bicentennial Man, and many others, even if they aren't 100% accurate. But what we haven't acknowledged is that AI technology, more particularly facial recognition, has been around for quite some time. So for the next section of this presentation, we're going to look at the past few decades in order to show how much this type of technology has evolved and transformed into what we have today. In the 60s, Woodrow Wilson Bledsoe developed a system that could categorize photos and different faces by hand using what's called a RAND device. The system worked by putting in horizontal and vertical line coordinates using a stylus. When the system records the locations of features, like where eyes are, nose, mouth, manually, then they are inserted into the databases. When it was given photographs of individuals later on, the tablet would be able to recover these images put into the database that looked closest to that person. Followed closely, accuracy increased in the 70s due to Goldstein, Harman, and Lesk. They were able to increase the precision of manual face recognition. The only difference here was that 21 subject markers like hair color, eye color, were used so that faces could be identified automatically. In the 1980s, Sirovich and Kirby put together the eigenface approach. It was a method that looked for low-dimensional images of faces. Through this, they showed that the analysis of different faces could give a set of generic or basic features, and also came to the conclusion that to correctly code a standardized face, you can use less than 100 values. You could say that at this moment, bias has started to creep in, because what exactly is a standardized face? As we all know, as a whole, races do tend to have different features. So at this point, how can we be so sure? Shortly following that, Turk and Pentland's contribution to Sirovich and Kirby was finding out how to find faces in different photos and images. This was actually a huge step that opened the door to automatic facial recognition. Into the 90s, DARPA and NIST put together a program that pushed out face recognition technology in hopes that it would encourage other facial recognition softwares in the market. In 2003, the database containing facial images was restructured to have high resolution, 24-bit color versions of images. So at this point, things were getting more inclusive. 2,500 faces in the project represented almost 900 different people. And now to break into this century, during the 2002 Super Bowl, police and much of law enforcement decided to implement facial recognition technology during the game. Unfortunately, this only resulted in finding out facial recognition really couldn't handle analyzing big crowds. It resulted in false positives and only picked up on a few people who were deemed as petty criminals. At that time, the system just wasn't ready to be used as a security measure. But soon after, NIST started to implement facial recognition vendor tests that were specifically made to give law enforcement and the government insight needed to decide the best way to implement facial recognition technology. And once AI hit 2010, it started to be implemented a lot more as security measures and enforcements. In 2011, Panama put Face First in place to suppress illegal activity of drug smuggling and organized crime through their Tocumen airport. And within the same year, face recognition spiked in usage in the US. It was then used more as a way to figure out who people were once they had died, and was used on Osama bin Laden when he died in the raid. As of now, we don't think too much about AI. Most of us use it every day when we use it to unlock our phones. AI is so normalized that we put it in a device we use every day. And not only that, have even convinced ourselves that a fingerprint unlock, something that is completely unique to us, is outdated, and that facial recognition is the new optimum security feature. As you can see, throughout the years, artificial intelligence has become more and more prominent, to the point of finding its place in two huge fields, healthcare and profiling. However, as it became more widespread, the biases have become worse and continue to grow. So before we hop into healthcare, let's take a moment to imagine a scenario. Imagine you're person A, and another person is person B. You're both sick with possibly the same ailment at the same pain level, and you both need immediate healthcare, but just to make sure you both need the same amount of help, doctors get artificial intelligence to help out. However, all it ends up doing is referring you to your physician, while it refers person B to make a speedy appointment by knocking them up a long waiting list for treatment. So why does this happen? Why would it happen? Algorithmic bias is a culprit of producing wrong results. It's a mirror image of what algorithms are choosing to use, their practices, and how the results are put into use and interpreted. And now that you, person A, have gotten to your physician, it feeds into the system once again that people like you, when they come in with this possible illness or your pain level, should most likely be referred to your physician. This AI is learning from repeated action, and maybe even worse, by the little data they even have on your demographic. Through some research, I found that healthcare, provisional to be exact, involves two information tasks. The first is the screening and diagnosis, and the second is treatment and monitoring. During the first step of diagnosis, we have the grouping of cases based on history and examinations. During the second, we have the process of planning, applying, and monitoring the outcome. While this process is quite basic, there are some flaws that lead to controversial decision-making, which overshadows the actual potential artificial intelligence has in the modern world of medicine. To understand the rationale behind the introduction of AI into healthcare, I found a study on why it may be needed. In a 2019 systematic review of pain management, it was found that people of color are least likely to receive pain medication than white people. This discrepancy for Black people was up to 40% less likely, and for non-white Hispanics, it was 25%. But this was because many nurses and doctors worked off conscious or unconscious biases based on a multitude of different factors, such as ethnicity, race, and even class. Thus, the introduction of artificial intelligence. The purpose here was to attempt to make more impartial decisions and actually provide a way to care for patients more efficiently. The fact that it relied on algorithms and was able to approximate features such as disease frequency between demographics was groundbreaking. It was able to be fed millions of records that turn that information into how to recognize specific groups and the contributing factors. By doing this, the AI machine is able to learn how to make distinctions. as long as it has enough data coming in from a variety of groups. So let's address what happens when there is this missing data. Missing data happens when the only available data is taken from what's called academic medical centers. When the AI technology gathers the data from that source, it's unable to get information on the different demographics it needs to make accurate readings due to them not often seeking care at those centers. A real example of this would be an instance where a healthcare organization was unaware that when they were developing product to sell to hospitals in order to help identify needy people that required care management, the algorithm was biased. It actually used historical data to calculate how severe an illness was. However, it didn't take into account historical racial inequalities where people of color couldn't receive the same care as white people. Back then, hospitals spent less money treating Black people, which meant that hospital records only had records of them being severely ill. They didn't spend money on the ones who were ill but not ill enough. But their white counterparts did get that treatment, whether life-threatening or not. This actually caused the AI to incorrectly group actual sick Black people with healthier white people, sorry. Even the discrepancy between wealthy and rich, or insured and not insured, can make a difference in whether artificial intelligence will be more inclined to give certain demographics substandard medical treatment. See, when a machine algorithm can't access enough groups to collect data from, it's much easier for the entire system to fail when it comes to assigning outcomes for those patients. If patients receive different care or are regularly misdiagnosed based on societal factors, the AI algorithm will pick up on this and begin to turn these biases into facts and actual recommendations for future patients. Giving different demographics access to help AI machines learn is imperative for not only technological advancement, but livelihoods. We need to enhance fairness, accuracy, and efficiency to reach and fix these past mistakes. Some ways we can attack this is through identifying these target populations, the populations we don't have enough information on, choosing them for training, and setting appropriate testing for them to take part in. This is the most effective way to actually build and test new algorithms, both socioeconomically and racially, so we can diversify more healthcare systems. Even better, develop feedback loops to monitor and verify output validity. The multiple variables of race, ethnicity, language barriers, and social implications that can sometimes impact healthcare accessibility need to be dismantled in order to ensure that the collection of data AI machines use and what it outputs is less prone to exhibit biased results. Our first step has to focus on inclusivity. Profiling and accuracy. When it comes to artificial intelligence, has been extremely difficult. The relationship between people of color and artificial intelligence's facial recognition is close to terrible. It started as a way to help identify people in pictures or unlock phones. But along the way, it became a means of catching criminals. False arrests, missed flights, unlawful imprisonments, police encounters, watch lists, and it got to the point of even giving people longer prison sentences. These are all factors of AI technological shortcomings and failures. According to the National Institute of Standards and Technology, systems falsely identified Black people and Asian people at 10 to 100 times more than white people. In papers from MIT and Stanford, researchers found that lighter-skinned men's error rate never reached above 0.8% in 3 different programs, whereas dark-skinned women scored up to a 20% error rate in one case and more than 34% in the other 2. Though many people are aware of the discrepancy in successful identification between white people versus people of color when it comes to criminal investigations, what is even more concerning is how AI is used leading up to arrests and after those arrests. Predictive policing tools are a means to identify if an individual is going to commit a crime in the future. Some algorithms are location-based, meaning that the data predictions come from linking places, events, and past crime rates in order to calculate where the next crime is most likely to happen. For example, a big event like a sports final or an important conference may have more police than usual. One popular patrol tool is called Predpol, which neatly grids out cities and updates officers of different crime predictions throughout the day. In fact, most police find the idea of predictive tools to be quite positive. It allows them to stop crime before it happens based on data about people, such as age, ethnicity, gender, history of substance abuse, marital status, past crime, and more. They believe that through the tool, it'll help push crime rates down. However, though it's a positive for police, it's been a huge negative for years for people of color. Although some police would actually use this predictive information to tell people that they were being watched or to control any future criminal temptations, it was found that people who committed crimes later on in life were actually given harsher charges. And this was all because a predictive tool and an officer decided to tell that person years ago. It only took one warning to result in a harsher charge. And now, when it comes to sentencing, artificial intelligence becomes even more of an issue and more of a threat to people of color. Using artificial intelligence technology most often marks white defendants as low risk at a much higher rate than Black defendants. It commonly flags that those Black defendants are more likely to commit future criminal offenses. And this prediction read that not only was there a probability that it may happen, but those Black defendants were twice as likely to commit another crime than white defendants. For example, COMPAS, otherwise known as COMPAS, is a tool that many jurisdictions presently actually use when making hard decisions about pretrial releases and other sentences and sentencing. It gives statistical scores between 1 to 10 to provide how likely it will be for the person in question to be rearrested if they were to be released. What clearly exposed the issue of risk assessment were the cases of Vernon Prater and Brescia Borden. Borden had had 4 juvenile misdemeanors in her entire life, and her partner, Prater, had priors of 2 armed robberies and another attempted armed robbery. Both were booked in jail, but the artificial intelligence program gave a high risk score of 8 out of 10 for Borden and a low risk score of 3 out of 10 for Prater. And within the next 2 years, Prater was the only one to reoffend. Regardless of the continuous errors in risk assessments, they're being used more and more, deciding who will get low bond amounts, deciding who will be released. And these 1 to 10 scaled assessments are provided to judges during criminal sentencing in states across America, like Colorado, Virginia, Delaware, Louisiana, and more. One of the main reasons predictive tools fail to be fair is due to the fact most use arrest data. This means of data accumulation and gathering doesn't do predictive machines justice, since not all arrests turn into convictions. This method of artificial intelligence has unfortunately become quite mainstream in the past few years. In 2016, the Brennan Center for Justice filed a suit against the NYPD for not providing information on how they carry out predictive policing. But when time came, public records only showed that the NYPD paid $2.5 million to a company called Palantir, who develops predictive tools, but there was no trace on what the purchase actually was. The police department nor Palantir would disclose what the payment was even for. But thankfully, the POST Act was passed, which forced such technologies to explain how they impact the residents in their specific city. As AI technology increases in demand, a lot of worry has come from its widespread use. The errors overshadow the successes, and yet that doesn't seem to be quite enough in order to fix these systems. It magnifies bias found in data sets and amplifies the discriminations against minorities at large scales. Policing, government, public sectors, and more need to take the time to set up dialogue with developers and ensure that rules surrounding data values include diverse representation to halt these consistent biases that impact minorities and begin to build with a more inclusive mind. What needs to be done is an examination of the pattern making that goes on and try to deconstruct the problem at its root. As AI increases, the importance to rid that obstacle becomes an increase in importance. Categorizing and understanding how to stop artificial intelligence's systems failures is what will help us move forward and build bigger and better machines that will help an array of individuals, no matter the demographic they live in or lie in. Obviously, at the end of the day, we can't get rid of bias completely. It's something that is both conscious and unconscious. And as long as bias is present, it'll be reflected in the data sets no matter what. What people need to do is become specifically aware of the particular instances where diversity is pertinent. Algorithms aren't what's wrong with artificial intelligence. They're inputted correctly. They work and run fine. There's nothing that engineering necessarily needs to change systematically. What needs to change is the initial approach. This needs to be changed because the choice of data input and performance measures is all reliant on what is primarily fed into the machine. In addition, considerable judgment is required to optimize future artificial intelligence performances, and most important, diversify data science teams. Being different in areas such as life experiences, skills, and hobbies will be a huge help when trying to pinpoint potential sources of bias, as well as becoming more familiar with the difficulties that those underrepresented groups face and are constantly and on a daily basis targeted by. We shouldn't just include underrepresented demographics into discussions, or give a lot of money to them so they can maintain and encourage inclusive growth, or run a workshop or two. Diverse people just need to be some of these people making decisions and actively driving the decisions and discussions of these biases in AI, along with how we can remedy them. Until we're satisfied with representation and inclusive data, artificial intelligence will never really be able to close that gap filled with errors. And the more we move forward, the less some people will be willing to double back to fix the issues we should absolutely be fixing right now. So let's start now. So I'd really like to thank everyone who watched this presentation, the ID24 team, and also the people who may watch this at a later time. I know it fell a little short, but I'm always open for people reaching out and having further discussions with me over my LinkedIn, which I'll provide on the screen. Do you agree? Do you not agree? Are there points you wish I talked about? I'd love to have any further conversations with any of you. So I'd love to hear from you guys in the future. Thank you.
Great, thank you very much, Jackie. That was excellent, highly informative, and a subject that I think many members of the technology community realize is extremely important and has obviously risen to considerable prominence recently. Heather, do we have any questions on the YouTube chat at all?
Yes, I did not see questions on YouTube, but I have one question of myself. Which is when someone is a doctor, they sign an oath, like the Hippocratic Oath.
Mm-hmm.
Does something like this exist for AI researchers?
I'm sorry, can you repeat the last part of your question?
Does something like a Hippocratic Oath, does that exist for AI researchers? So people who work on these algorithms.
Yeah, so the main point I was really trying to stress is that you can always sign, something with like a HIPAA form, but oftentimes the data sets are really driven by unconscious biases. So in my wrap up, what I was trying to really get at is trying to round up these diverse thoughts and put these diverse people in these different teams. So unconscious biases in AI machines are significantly lowered because it is really hard to expect people to no longer have any biases when they're fixing machines, no matter how many papers they do sign. It's just a psychological fact that prejudice is actually built inside of us, but it's definitely not something that signing a paper can get rid of, honestly.
Right, so the only way to really fix this bias is by having more diverse people, so that they have
absolutely
diverse biases.
Is there sorry, go ahead.
One other thing that I was wondering, because you mentioned so much different research during this talk, which was great. Was there anything that stood out to you while you were doing research for this talk?
I think what was I actually went into this not knowing anything about AI. So I really was shocked by the case between Brescia Borden and Brennan Prater, because having two people at such different ends of the, I guess you could say, criminal spectrum, and having a machine actually rate someone at a lower risk who has done more severe crimes just because of their skin color was extremely mind-blowing to me. And I honestly didn't even know that there were these predictive tools that impacted people to this magnitude. So I think that during my research, that was the most shocking thing that I did come across.
It sounds like you know, there's something of a paradox in this that quite possibly occurs in other areas too, in the sense that you know, years ago people used to say that you know, computer programs were only as smart as the people who program them, and it almost seems that actually stands true in this case. Only here we've got the problem of AI is only as capable as the data it receives, and the data it receives is dependent on, you know, the balance of the humans involved in doing it. Do you think that means essentially we've got to try and fix humanity in order to fix AI? Is it that much of an enormous task ahead of us?
I think it really is a big task, which is, I feel we do have to attack it sooner rather than later. I know that the humanity part of your question, I'm not sure if I think that's a little more like wishful thinking. I'm not sure we can actually achieve that, but I really do think that data science teams are what we really need to focus on when it comes to a wider breadth of knowledge on diversity and inclusion. So I think we just need to be really careful about who we bring onto teams that actually have these huge impacts on people's lives, which can be, you know, life or death, or being able to pay a bond to stay out of jail. And it's really a big thing that I think that if we move forward with AI at this point, it might fall through the cracks, and people might not want to double back and uproot AI and start from the stem of the problem and rebuild from there.
Right, because I think when people see just an enormous task ahead of them, it becomes too daunting and almost people never get started. But actually what you're suggesting is a very small, very manageable and achievable step in the right direction. That you know, that's always good strategy, I think, isn't it?
Yeah.
Hida, did you say we had a couple more questions?
Yeah, we have some more questions from YouTube. We have Mukesh Sharma, who said the problem of poverty is kind of circular in nature. Do you think the problem of bias is similarly circular in nature? Is that a problem for bias?
Sorry, can you repeat the first, which circular, and can you repeat the question?
The problem of poverty
Okay.
is circular in nature, said the person. And they wondered whether that is the same for bias.
I think that's a really good question. I'm actually not sure. When you say this might actually just be a question back to that person, can you explain a little more what you mean by poverty is circular in nature? Just so I can, you know, make an accurate response.
Hope they are listening and they may be typing now.
Okay.
We'll go into some other question in between. When it comes to unconscious bias, Stephen Barras is asking, is there a direct correlation between AI data and the team that built this AI tech?
Yeah, I definitely think so. The whole premise of the bias in AI is due to the data sets it runs on. So, and those data sets are provided by, obviously, you know, the data scientists. They're human. They have implicit biases. They have unconscious biases. So once these things go into these machines, it's just a continuous learning cycle of, okay, you know, when I type in tall basketball player, maybe it'll result with a tall Black person. You know, it's a continuous learning mechanism. So if the people putting in these biased data sets, whether they know they're biased or not, it's always going to be reflected in that artificial intelligence machine.
Do you think there's an element also of getting the public involved in AI design, in the sense that, you know, when we're building websites or apps or things like that, we sooner or later usually do some form of usability testing with people from the general public? It just occurs to me that taking your model of having, you know, a number of experts working on a project from diverse backgrounds is absolutely critical. But there's sort of a danger perhaps of the common ground of expertise itself becoming a blocker. Is there a place for, bringing in that kind of really random general public perspective in AI design, do you think?
I think that when maybe building certain machines, maybe for, let's just say, for the sake of this presentation, let's just say healthcare, when building certain machines, I do think that the general public, it does play quite a big factor, just because having different skin tones or having different features is really important when it comes to the development of these different machines. There's only so much data scientists can do because they're just in charge of putting the data sets out there. So a lot of the time, to answer your question, yes, the general public would be very helpful in kind of combating these biases by volunteering their time or coming in to be part of some of these testings. So along the lines of usability tests.
Great. I have another question, unless we have any more from the social media channels. Hida?
Oh, go ahead, Lenny.
I was curious, Jyrki, in your research, did you come across variations on a theme of the same biases from different parts of the world? In the West, as you explained in your talk, we've got color bias that tends more often than not to be along the sort of the black-white lines. Is it such a thing that if you were to look at technologies coming out of Asia, for example, we're seeing the same racial biases, but on different color frameworks, if I can phrase it like that?
I came across some studies on Asian features. I know that isn't a lot of the times white people and Asians, they share more or less the same skin color. So I came across more facial features where things could become a little skewed when trying to match up different faces. But overall, I found that facial recognition technology in the Eastern world is a lot better than what we have here in the Western world. So I don't have a ton of information on things such as facial or what you're asking, like East versus West, but that is a good question. I would love to look into that more. But yeah, I only really looked at facial features, nothing further than like height or different skin colors. So yeah.
Yeah, no, you're right. And I suspect, my hunch is that the answer is yes, it does exist in different forms, because as you quite eloquently pointed out, we're all human, and we'll have some biases, no matter how hard we try.
Yeah, like different, obviously, we all know that different races have different features. So there will be racial bias regardless, I think, of the race that you are, whether that's a positive bias or whether that's a negative bias.
Yep, absolutely. Well, I think we're out for questions. We didn't get a reply from our YouTube person, but if they do get back in touch, then we'll let you know and try and connect that dot. Jyrki, once again, thank you so much. This was a really terrific talk. We very much appreciate it. You've been fantastic.
Thank you so much.
Thanks also to Hida, who's done a terrific job of co-hosting over the past few sessions. Really appreciate your help too. It makes all the difference to the smooth running of things. Thank you. Lastly, thanks to our Platinum supporters, Adobe and Barclays Access, and our Gold supporters, Intopia, InfoAxia, and Tetralogical. A reminder that ID24 will be back with you on the hour, so please take time to refresh yourselves and grab a break, and we will see you in a few short minutes.